Hello, class. Please forgive me. I have a little nasal congestion going on right now, so my voice is a little different, and I will occasionally be blowing my nose or getting a drink of water. So just bear with me as we go through this. Now, I want you guys to watch this video before we get into all the activities that I have planned for us tomorrow. It will just make tomorrow go smoother. It will help just make the day go by a little bit quicker and more efficient for us. So our topic for tomorrow that I really want to go over tonight is air pressure. Now I want you to think, you've ridden in an elevator, I'm sure most of you guys have, and the higher you get, your ears, you can't hear after a while. You suddenly are not able to hear. So then you swallow and pop, right? Your ears just pop, and you can hear better. You know, it feels a lot better, and you know from then on, anytime you swallow, when your ears feel like that, it goes away. The question is, though, what caused your ears to pop? How did that happen? Why did it happen? That's what we're going to go into today, that phenomenon and everything associated with it. Now, that phenomenon would be air pressure. Now, this is going to be a term that we want to keep in our vocabulary books. It is called air pressure, and what it is the amount that air presses on or pushes on anything. Now, you usually won't notice all the pressure, or the air pressure rather, but you will notice its effects. And a great example of that would be in the elevator. You didn't notice the air pressure or the pressure at all when you're on the elevator until your ears started to feel weird, and then you swallowed and they popped. So, although you didn't notice it, you will definitely notice the effects of it. Now, you might be asking yourself, is this true for every single time you go high up in the air? Well, I want you to think, if you're riding in an airplane. Normally for me, my ears start to feel the way they do when I go on an elevator, and I have to swallow to make them pop. So yes, it seems to be that every time you get higher, the pressure is going to affect it, and your ears will start to feel that way. Now the thing, though, about air pressure is you would think that it would be greater the higher you go because you're experiencing that feeling in your ears. That actually is not the case. As you travel higher above the earth, the air pressure will then change. So higher you go, the less pressure you have. Okay? I want you to remember that because it can be a little confusing since, normally I was in the same boat when I was a student. I thought, the higher you go, the greater pressure there would be, but it's actually the other way around. The higher you go, the less pressure. Now, I want to get into what also changes the higher you travel. It's not just air pressure, but also temperature. Okay? Now, I don't know how many of you have gone hiking on mountains or been to Colorado or even the Appalachian Mountains, just any mountain at all. But what you'll notice is that it's actually really, really hot, down below the mountain. But then the higher you go, the temperature starts to drop. Okay, so that's another way we can remember the higher you go, another thing starts to drop. So we have air pressure and we have temperature that are both dropping the higher you travel above Earth's surface. And the reason that is for the temperature is that the Earth's surface actually heats the air. And the farther from the Earth you are, the cooler the temperature. And that makes sense if you think about if you're trying to warm yourself up by the fire. You want to get close to the fire to really feel the warmth. But then the further you go, you're not going to feel that warmth anymore. It's going to be cooler for you. So think of that. Think of the Earth's surface as that fire that's heating the air, and then the further you go up, you're going away from the fire or the Earth's surface, so the air temperature is going down. Now, with low air pressure, we have air that is near the surface of the Earth. It becomes warmer. Again, that fire, the Earth's surface, the air particles will move further apart. Now the air will then become lighter, and then the air will rise. Now this is when a low pressure area forms. Okay. Now we also have high air pressure. Now this is going to be cool air. Now cool air is heavier than warm air. And in cool air or high air pressure, the air particles are going to be packed close together, and they're going to push down harder. So this is when a high area or high pressure area forms. So I want you to think, when we have low air pressure, the particles are moving further apart. When we have cold air pressure or high air pressure, they're going to move close together. Now the reason, or one thing that I tell myself to help me remember that, is that when you're cold and the cool air, you want to bundle up and get close to each other, huddle up with some people to get that body warmth going. So I feel like I see those air particles as just people trying to get warmer in the cool air, and that's why they pack close together. Alright, now let's move on to wind. Now, in yesterday's lesson, we learned a little bit about wind, and we learned that wind can push things, such as clouds, in certain directions. Now, it's also the same with all types of weather. Wind is basically going to help form these different types of weather that we'll see. And we'll just dive into a little bit of these weather, different types of weather, later on in this unit. We'll see like severe weather, hazardous weather, such as hurricanes and tornadoes, things of that nature. Now, air moves from a place with high pressure to a place with low pressure. Okay. Now, air moving, we know, is called wind. Okay. So when the cooler air from a high pressure area sinks toward the earth, well, then it causes wind. Okay. So let's remember that. When cool air from a high pressure area sinks toward the earth, because remember, high pressure area that those particles are pushing down anyway, it'll sink towards the earth, it'll then cause wind. That's why you'll feel a cool breeze even on a warm summer day, which is kind of really cool to think about, that it can be so hot, and yet the air, cool air pushing down is going to create wind, which will help cool us down. Now, there are a few ways to measure air pressure. One of those ways is barometer, by using a barometer. Now, as you can see, this barometer has a few different parts to it, okay? Now, we're not going to, as of now, we don't really need to know every single little piece involved in a barometer, but we definitely need to know its function, and that it does measure air pressure, okay? Now, you can measure wind direction as well. I'm sure you've seen these around, especially in Kansas. You'll see these kind of out in fields and stuff like that. And what these are called are wind vanes. Now it lets you know which way the wind is blowing, okay, the direction. Alright, you can also measure wind speed. Now this looks similar to our wind vane. However, with this we have an anemometer, and you can see we have these bowl shapes instead of the directions. So here we have the directions, north, south, west, east. But here we have these little bowl-shaped objects on the end instead of our directions. And those help measure wind speed. Now, tomorrow, when we get to class, we have a few activities, and one of those activities will be creating our very own anemometer. Okay? Now, I want you to remember this as a tool that scientists use to help measure wind speed. Okay? So really quick, let's recap. Alright, what causes wind? Well, remember that wind is caused by air moving from a high pressure area to a low pressure area. Okay, those high pressure areas have that colder air, that cooler air, and it's weighted down, or it's going to push down, because all the particles are packed together, and they become strong enough to where they can push that wind down, or the air down, and create wind. Okay, now air pressure is measured by an instrument called a barometer. Scientists can measure wind direction with a wind vane. And they measure wind speed with an anemometer. Okay? Now, sorry. Go back really quick. Now, what I really want you to remember from this video is the anemometer and the different pressures. High air pressure, which has cooler air, and low air pressure, which is warmer air. Okay? And basically, the higher we get, two things happen. One is the temperature will drop as we go higher, and 2, the air pressure will be less the higher we go. Alright, so thank you guys for taking time to watch this video. I'm excited to see you tomorrow in class, and we will briefly go over this again tomorrow, but we're going to pretty much jump right into our activities. So I hope you guys have a good night. Thank you.